study equation of motion. Last topic of lecture number 6. Today we continue with that one again, once again. That is equation of motion. For an object traveling a plane, with uniform acceleration. Acceleration is uniform. Now we have to prove the equation of motion in a vector form. Equation of motion in a vector form in a plane. Let u is the initial velocity at t is equal to 0 and v be the final velocity at a time t. Sometime it may be 5 seconds, 10 seconds, whatever it may be after some time. Now as the acceleration is constant, uniform acceleration, that means constant acceleration. We get constant acceleration. The average acceleration and the instantaneous acceleration is same for uniform case. Instantaneous and average acceleration is same for a uniform acceleration. And we know the definition of acceleration is change in velocity with respect to time. We know that for acceleration we use the small letter vector A. Vector A is equal to, according to by definition, change in velocity. Now see, change in velocity, that means difference between two velocities. V is the final velocity and u is the initial velocity. Therefore, now vector v minus vector u divided by, when the velocity is final, then time is t. Therefore, t minus 0. Therefore, we get vector A is equal to vector v minus vector u divided by t. We get the formula for acceleration, v minus vector v minus vector u divided by t. Now we know the equation of motion. We know the first equation of motion. Vector v is equal to vector u plus vector a into t. Now we get the average acceleration. For average acceleration, the velocity is average, v average. For average acceleration, v average, and how we get the average? We combine two velocities and take a mean. Therefore, v average in this case we get as a vector u plus vector v divided by 2. Because we are taking average velocity, and when we take the average, we added the number of velocities here, initial velocity and final velocity. Therefore, addition of two velocities and divided by 2. Now we know the value of v. Vector v is equal to vector u plus vector a into t. Okay. Now we know the formula for displacement. Vector s is equal to vector v into t. Velocity का formula है. Velocity v is equal to displacement divided by time. Therefore, for a displacement, it becomes vector s is equal to vector v into t. Now substitute the value of, here is v average. Therefore, displacement vector s is equal to vector v average average velocity. So substitute this value in this equation. Vector u plus vector v into t divided by 2. Divided by 2. Which is equal to, we know the value of vector v as equation of motion vector u plus vector a into t. Therefore, vector u plus, what is the value of v? Vector u plus vector a t into t divided by 2. Vector s is equal to vector u plus vector a into t. This is the value of vector v into t divided by 2. Now simplify this step, we get as a vector s. Vector s is equal to u plus vector u plus vector u plus a vector a into t and common multiply by t divided by 2. Divided by 2. Which is equal to vector s is equal to u vector u plus vector u. That means twice vector u plus vector a into t multiplied by t divided by 2. Divided by 2. Therefore, vector s is equal to twice vector u divided by 2. Separate this into t plus vector a into t square. T multiplied by t. या t ने आपण या ब्रॅकेटला मल्टिप्लाय केला. Therefore, we get twice vector u divided by 2 into t plus 80 square divided by 2. Now 2 get cancelled. Therefore, we get the equation vector s is equal to vector u into t plus 1/2 80 square plus 1/2 80 square. And we know that this is the second equation of motion. This is the second equation of motion in a vector form. But फर्स्ट इक्वेशन वरनं आपण सेकंड इक्वेशन जे आहे ते सेकंड इक्वेशन फाइंड आउट केलेलं आहे. हे सेकंड इक्वेशन ऑलरेडी आपल्याला माहिती होतं इन अ रेक्टिलिनियर मोशन. रेक्टिलिनियर मोशन मध्ये आपण तीन इक्वेशन जे आहेत ते तीन इक्वेशन्स फाइंड आउट केलेले आहेत. आता आपण मोशन इन अ प्लेन पाहतोय. दॅट मीन्स मोशन इन अ 2 डायमेन्शन्स x and y axis. सो x and y axis मध्ये ज्यावेळेस ऍक्सेलरेशन जे आहे ते ऍक्सेलरेशन युनिफॉर्म असेल, युनिफॉर्म ऍक्सेलरेशन असेल म्हणजेच त्यावेळेस आपल्याला ऍक्सेलरेशन जे आहे ते ऍक्सेलरेशन काय मिळतंय? कॉन्स्टंट मिळतंय. आणि कॉन्स्टंट ऍक्सेलरेशन असेल तर आपल्याला इक्वेशन ऑफ मोशन ऑफ दॅट ऑब्जेक्ट इन अ प्लेन, त्यावेळेस आपल्याला दोन इक्वेशन ऑफ मोशन जे आहे ते दोन इक्वेशन्स ऑफ मोशन्स मिळतात. ते कसे आपण प्रूव्ह केलेले आहे? अकॉर्डिंग टू बाय डेफिनेशन वेक्टर a इक्वल टू वेक्टर v मायनस वेक्टर u डिवाइडेड बाय t मायनस 0, that is change in velocities divided by time. So we get equation in the vector form as a vector a is equal to vector v minus vector u divided by t. Now we know the equation of motion, first equation of motion. So vector v is equal to vector u plus vector at. We get this is the first equation of motion in a vector form. Now we have to prove second equation of motion using 2 dimensions, and therefore we take as an average velocity. And we know the average velocity, that is mean of 2 velocities. It may be initial and final. Average करताना आपण काय करतो? टोटल जे रीडिंग दिलेले असतात त्या रीडिंगचं काय करतो? ॲडिशन देतो and divide by number of readings ने डिवाइड करतो. त्याच पद्धतीने आपल्याला जर ॲव्हरेज व्हेलोसिटी फाइंड आउट करायची असेल तर आपण काय करतो? वेक्टर u प्लस वेक्टर v डिवाइडेड बाय 2, because in this case we get only 2 velocities, initial velocity and final velocity. Therefore, vector v average is equal to vector u plus vector v divided by 2. Now, the object is in motion. Object is in motion. That is, there is displacement. So, vector s displacement in a direction. Therefore, vector s is equal to v average into t. We know the value of v average. Therefore, substitute here average velocity's value into multiply by t. And then we substitute the value of v by using first equation u plus at. The value is substituted, divide by 2 and multiply by whole bracket multiply by t. सिंप्लिफाय केल्यानंतर आपल्याला सेकंड इक्वेशन ऑफ मोशन जे आहे ते वेक्टर x इक्वल टू ut प्लस 1/2 वेक्टर x इक्वल टू वेक्टर ut प्लस 1/2 vector a into t square. This is the second equation of motion in a plane wave. So, if we give this as equation number 1 and this is the equation number 2, this is the second equation and we call it as equation number 2. Equation number 2 can be resolved. Equation number 1 and equation number 2 can be resolved into their x and y components. हे दोन्ही इक्वेशन जे आहेत ते दोन्ही इक्वेशन आपण x and y components मध्ये आपण लिहिणार आहोत. So this is the equation number 1. Vector v is equal to vector u plus ad, vector ad, and vector s is equal to vector u into t plus 1/2 vector a into t square. This is the second equation. This is the second equation. Now, these two equations can be resolved into their x and y coordinate, x and y coordinate plane. X and y coordinate plane. So, in x plane, vector v can be written as vector vx is equal to vector ux plus vector ax into t. And in y coordinate, this equation number 1 we can write as vector vy is equal to vector uy plus vector ay into t in x and y coordinate plane. Second equation we can resolve in its xy plane. So vector sx in x plane, vector sx is equal to vector ux into t, vector ux into t plus 1/2 ax, vector ax into t square in x plane. And in y plane, this displacement as vector sy is equal to vector uy into t plus 1/2 vector ay into t square. So displacement in a plane, second equation of motion, we can write in x and y plane also. That means displacement of object in x plane, we get vector sx is equal to vector ux into t plus 1/2 vector ax into t square. Similarly, in y plane, second equation of motion for displacement, vector sy is equal to vector u1 into t plus 1 half vector a1 into t square. Thus, we can see the motion along x direction of an object is completely controlled by x component of velocity. Motion of object is controlled by the x component of velocity, and acceleration along y direction. Acceleration along y direction is completely controlled by y component of their equation. Y component of this equation. So using x and y axis, we can prove second and first equation of motion in their components. Next point is relative velocity in a plane. हे समजलं असेल तर आपण नेक्स्ट पॉइंट जाणून घेणार आहोत. दॅट इज रिलेटिव्ह velocity in a plane. It's similar as we already studied relative velocity in rectilinear motion. So what is mean by relative velocity? That is, we have taken the difference between two velocities. So relative velocities between two objects moving in a plane. Now object is moving in a plane defined in a similar as that object moving in straight line, straight line. For example, this is the motion of the object A in a straight line. Then similar direction, the motion of the object B. Then these two objects are in relative motion, as we already studied in rectilinear motion. So we can define these relative velocities between these two objects. Relative velocities of object A relative velocity of object A with respect to object B. जसं आपण रेक्टिलिनियर मोशन मध्ये पाहिलं, फॉर एक्झाम्पल तुम्ही ट्रेन A वरती ट्रॅव्हलिंग करत असाल आणि बरोबर सायमल्टेनियसली सेकंड ट्रॅकवर B ट्रेन जात असेल, तर B ट्रेन ज्यावेळेस तुम्हाला ओव्हरटेक करून जात असेल आणि ओव्हरटेक करून जात असताना तुम्ही त्या B ट्रेनकडे पाहत असाल, तर तुम्हाला B ट्रेनचं जी काही स्पीड आहे तो स्पीड स्लो झालेला दिसून येईल. दॅट मीन्स पाहत असताना आपल्याला ही जी काही B ट्रेन आहे त्याचा स्पीड जो आहे तो स्पीड स्लो दिसेल. याचाच अर्थ आपण ह्या दोन्ही वेलोसिटीज मध्ये काय रिलेटिव्ह वेलोसिटीज आहे, रिलेशन आहे, बिकॉज दे आर ट्रॅव्हलिंग इन अ सेम डायरेक्शन विथ रिस्पेक्ट टू each other. Therefore, relative velocity of object A with respect to object B in a plane also same process. In a plane, that means in x and y coordinate also we get the same relative velocity as we already studied in rectilinear motion. That means along straight line. So velocity of A. Now relative velocity of A with respect to B, which is equal to velocity of A minus velocity of B. How we write as velocity of A minus velocity of B, and it is a vector. Therefore, relative velocity of vector AB is equal to velocity of A vector VA minus vector VB. If If we want to find out relative velocity of B, if we want to find out relative velocity of B with respect to A, then in a formula we can write this relation as vector phi BA. How we write this? Relative velocity of B with respect to A. And in this case, a relative velocity of A with respect to B. Therefore, the formula becomes vector Pb minus vector Va. Relative, how we write this? Vector relative velocity of B with respect to A, which is equal to vector Vb minus vector Va. Now, by these two formula, we study only two objects which are going in a similar direction. These two objects, if there are more than two objects which are moving in a relative motion from A, B, C, D up to Z point, there are number of objects which are moving with respect to each other. Then their relative velocity we can find out, or then their relative velocity we can write as, for example, consider a number of objects from A, B, C, D up to Z moving with respect to each other. Moving with respect to each other. For example, there is object C, there is object D up to Z object. Then their relative velocities we can write as relative velocity of vector A with respect to vector B, relative velocities of vector A to vector Z. Now the object is up to point Z, and this is x-axis, and below relative velocity between A to Z. Then relative velocity of A to Z, we can write this in formula as vector A B minus vector B C. Now in this case we have to find out the total relative velocity from A to Z. There are number of objects. Therefore, we have taken here plus vector A to B, vector B to C, plus vector C to D, plus vector D to E, up to vector Y to Z. Vector Y to Z. Vector A, velocity A to B means velocity of A minus velocity of B. Like this way, we can find out the relation between these objects' velocity from A to Z, and we call it as a relative velocity. In a plane also, we can find out the relative velocity between two objects. So the next point is next important point, and it is different. Up to this point, we studied the object moving in a plane. Object moving in a plane. Object plane मध्ये move होत असेल x and y coordinate system मध्ये, that means 2 dimension मध्ये, तर त्या डायमेन्शन्स मध्ये मूव्ह होत असताना त्याच्याशी रिलेटेड जे काही कन्सेप्ट आहेत ते आता आपण पाहिलेले आहेत. फॉर एक्झाम्पल युनिफॉर्म एक्सेलरेशन असेल, इक्वेशन ऑफ मोशन असेल, किंवा रिलेटिव्ह वेलोसिटी असेल. हा सगळा जो स्टडी आहे तो आपण कुठल्या ऑब्जेक्टचा केलेला आहे? व्हेन ऑब्जेक्ट इज मूव्हिंग इन एक्स अँड वाय प्लेन. एक्स आणि वाय या दोन सिस्टीम मध्ये, दोन कोऑर्डिनेट सिस्टीम मध्ये तो ऑब्जेक्ट जो आहे तो ऑब्जेक्ट काय होतो? मूव्ह होतो. अँड अप टू दिस पॉइंट this is the last point of object moving in a plane. Next new point is the projectile motion of an object. So next point, projectile motion. Projectile motion. This is the new point of or it is the third point of motion. Type of motion, third type, projectile motion. So what is mean by projectile motion? Any object in a flight after being thrown with some velocity is called as a projectile, and its motion is called as a projectile motion. I read again. Any object in a flight after being thrown with some velocity is called as a projectile, and its motion is called as a projectile motion. For example, children throw a stone towards trees, and second example, a basketball players throw a ball towards the basket. The motion of the object or motion of the ball is like this. Motion of the ball or motion of the stone is like this. Throws in upward direction object, and up to some height with respect to ground, the object returns towards the ground. And this type of motion we call it as a projectile. त्या ऑब्जेक्टची जी काही मोशन आहे त्या मोशनला आपण काय म्हणतो, प्रोजेक्टाईल मोशन असं म्हणतो. आणि तो जो काही ऑब्जेक्ट आहे जो आपण थ्रो करतोय त्या ऑब्जेक्टला आपण काय म्हणणार आहोत आता, प्रोजेक्टाईल असं म्हणणार आहोत. मीन्स इट मे बी स्टोन असेल किंवा बॉल असेल, तर तो जो काही बॉल किंवा स्टोन असेल त्याला आपण काय म्हणणार आहोत, प्रोजेक्टाईल म्हणणार आहोत इन्स्टेड ऑफ ऑब्जेक्ट. सो प्रोजेक्टाईल traveling a path with respect to ground is called as a projectile motion. So projectile motion आणि त्याच्याशी रिलेटेड जे काही टर्म आहेत त्या टर्म आपण पाहणार आहोत. पण डेफिनेशन द्यायची, डेफिनेशन तुम्ही लक्षामध्ये ठेवायचे. An object in a flight after being thrown with some velocity. An object in a flight after being thrown with some velocity is called as a projectile, and its motion is called as a projectile motion. For example, I repeat the example once again. Children throw stones towards the trees. Observe or imagine a picture when a stone is thrown towards the tree. The motion of object is like this. Now we call the object as a projectile. So some important point we have to remember in case of a projectile. In case of projectile, first point we have to remember in a projectile motion. Projectile motion मध्ये काही points जे आहेत ते आपल्याला कायमस्वरूपी लक्षामध्ये ठेवायचे. First point जो आहे, the projectile has two components of velocity. प्रोजेक्टाईल ज्यावेळेस आपण प्रोजेक्टाईल मोशनचा स्टडी करतो, प्रोजेक्टाईलचा स्टडी करतो, त्यावेळेस तो प्रोजेक्टाईल जो आपण यूज करतोय, प्रोजेक्टाईल हॅज टू कंपोनेंट्स ऑफ वेलोसिटी, वन इन हॉरिझॉन्टल and that is along x direction, and other in vertical that is along y direction. Along y direction. That means here we get the motion of a projectile like this. We have to study here two velocities. Horizontal component of a projectile. Horizontal component that means along x-axis, and vertical component that means along y-axis. Now the velocity along x-axis we call it as a horizontal velocity. When object thrown from point O with respect to x-axis, then the initial velocity of that object is u, and along x-axis it is ux, and along y-axis it is uy. initial velocity. Therefore, we use the letter U along initial velocity along y-axis and initial velocity along x-axis. This is the important point. First, we have to remember. Second, the acceleration due to gravity acts only along the vertically downward direction. The acceleration on projectile due to gravity acts only along y direction. यावेळेस ऑब्जेक्ट जो आहे तो ऑब्जेक्ट y डायरेक्शन मध्ये, that means in topward motion, object having acceleration due to gravity in vertically downward directions. The point repeat again. The acceleration due to gravity acts only along vertically downward direction. This is the second important point. First important point, we get the velocity of a projectile. Velocities of a projectile along x and y direction. We call it as a horizontal velocity of a projectile, and along y direction there is a vertical velocity of a projectile. If it is a initial, we can denote as a ux, and if it is a final, we can denote it as a vx. Along y direction, again it is the initial velocity, then we can write as a uy, and if it is a final velocity, then we can write as a vy. This is the first point we have to remember when projectile, in the case of a projectile motion. And second point, acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity acts only vertically downward direction. Acts only vertically downward direction. Acts only vertically downward direction, and vertically downward direction, that means along y-axis. Along y-axis or along y direction. Third important point, the horizontal component. Third important point of a projectile, the horizontal component of velocity remains unchanged. The horizontal components of velocity, that means along x-axis remains unchanged. And as x-axis ला the projectile ची जी काही velocity आहे ती unchanged राहते, त्याच्यामध्ये काही चेंज होत नाही. का चेंज होत नाहीये? As there is no force of acting in a horizontal direction. Horizontal axis चे कुठलाही फोर्स आहे तो फोर्स काय होत नाहीये, ऍक्ट होत नाहीये. त्यामुळे आपल्याला horizontal component of velocity along x-axis जी आहे ती काय होते, unchanged मिळते. That means vector velocities are with respect to time unchanged ahead. That means acceleration ax along x direction, acceleration along x direction we get as a 0. And fourth point we have to remember, that is vertical component change in accordance with vertical components. That means along y-axis. That means along y-axis, vertical component changes in accordance with laws of motion. That means we can write as vector ay along y-axis. We can write as a vector ay is equal to minus g. Vector ay is equal to minus vector g. downward acceleration due to gravity. माइनस जी माइनस व्हॅल्यू का घेतलेली आहे कारण ऑब्जेक्ट जो आहे तो ऑब्जेक्ट काय होतोय डाउनवर्ड डायरेक्शन ने येतोय डाउनवर्ड डायरेक्शन दॅट मीन्स अपोजिट टू ग्रॅव्हिटी therefore we can take it as a minus g being downward acceleration due to gravity that is retarding force like air resistance are neglected. Retarding force आहे त्या ऑब्जेक्ट वरचा एक पॉइंट that is air resistance of a projectile is negligible. These 5 points we have to remember while studying when the object is in projectile. Now we call the object as a projectile. When the projectile is in motion, we have to remember these 5 points. First point is velocity along these projectiles contains 2 velocities. Along x direction, we call it as a horizontal velocities of that projectile and we call it as a ux. This horizontal velocity of projectile along x direction. Velocity along y direction we call it as a vertical velocity. If the object or projectile is moving along y direction, then we call it as a vertical velocity and we denote this vertical velocity as uy and phi. Uy is the initial velocity and phi is the final velocity. Acceleration due to gravity, that means vertically downward direction. The projectile वरती जे काही along y direction ला आपल्याला जी काही velocity मिळणार आहे it is vertically downward direction. Next point, along x axis the velocity remains unchanged. That means acceleration is equal to 0. The object is moving in vertical direction. It is not moving in along x direction, in vertically upward direction, that means along y axis. Therefore along x axis we get acceleration as a 0. Next, fourth important point, that is we get the projectile acceleration along y axis as vector ay. I repeat again, acceleration along projectile acceleration along y axis we taken as minus g because on that projectile gravitational acceleration is in downward direction, therefore we taken as a minus g. Air resistance on a projectile should be negligible. Air resistance on that projectile should be negligible. These 5 points we have to remember while studying the motion of a projectile. So what is meant by projectile? I repeat the definition. An object in a flight after being thrown with some velocity is called as a projectile and its motion is called as a projectile motion. Now we have to find out its equation of a projectile in vertical and horizontal direction. When we throw the object from point O and it reach at point Q, that means along horizontal x axis. So this is the origin point and this is the final point where the projectile reach. This distance we call it as a range of a projectile. या distance ला आपण काय म्हणतो range of a projectile असं म्हणतो. ऑब्जेक्ट प्रोजेक्टाईल जो आहे तो प्रोजेक्टाईल थ्रोन केल्यानंतर मॅक्सिमम हाईटला अलॉंग वाय ॲक्सिस मॅक्सिमम हाईट पर्यंत गेला. ती जी काही मॅक्सिमम डिस्टन्स आहे फ्रॉम एक्स ॲक्सिस टू that projectile, that distance we call it as a maximum height or height of a projectile. That is the vertical distance of a projectile, and that vertical maximum distance of a projectile we call it as a height of a projectile. and the total time required for the projectile to complete the path. Total time required for the projectile to complete the path is called as a time of flight of a projectile, and time of a flight we taken as a capital T, and the path covered by the projectile. Total path covered by the projectile we call it as a path of a trajectory. Total path covered by the projectile we call it as a trajectory, path of a trajectory of a projectile. So we have to find out equation of range of a projectile, equation for height of a projectile, and the equation for trajectory of a projectile. These equations we will find out in tomorrow's lecture. So up to this point today we stop here. Thank you.